We're going to do section 7.2. We're going to solve linear systems by substitution today. I ask that you get out a different color pen or pencil because you're going to be drawing some railroad tracks. You're going to be drawing some arrows around to help yourself understand what to do. So I should get out a different color pen or pencil. If you're using pencil right now to take your notes, get out a pen. I'm going to be using different colors up here to help me. Put down the system, y equals 2x minus 3, and x plus 3y equals 5, and we are not graphing. So put away your notebook right now, the workbook, and have your notebook for notes out, please. Substitution is an algebraic way of solving a linear system. Because we all know graphing's not the best for everything. We kind of determined that in the last information we were just talking about. When you do substitution, you have to have one of your equations solved for y or the x. One of the equations must be solved for y or x. It honestly doesn't matter which one mathematically, but sometimes one is easier than the other depending on the problem that you're working on. Please notice that I have y equals 2x minus 3 already written up there as one of the equations. I have it in y equals. Thus, I've solved it for y for you. Now, what we're going to do is we are going to substitute what y is equal to in the other equation for y. We're going to put what y is equal to in the other equation for y. So I'm going to start writing the other equation as x plus 3 times what y is equal to from the first equation, that 2x minus 3. Now the deal is, I want to get it so that my equation only has one kind of variable in it, because then I can solve for that variable. Let's do a little distributive property here. X plus, what's 3 times 2x, class? 6x, very good. How about 3 times a negative 3? Negative how much? 9. I was hearing a couple different answers. Should be negative 9 equals 5. Gather our like terms together as always. So x plus 6x is how much, class? 7x minus 9 equals 5. Hey, this is a two-step equation. Chapter 3, coming back to see us. How do we start solving this two-step equation, please? How do we start solving it, Kyle? Add 9 to both sides. And what will that give you, Kyle? 14 on the right side. On the left side is just the 7x. Now it's a one-step equation. How do we solve that one step, Jordan? Divide by 7 on both sides. And so x is, Jordan? 2. Okay, you just found out what x is. And now we are going to substitute that back into the equation for x. Now I can substitute it in here, or I can substitute it in here. It does not matter which one I substitute it back in for. Hint to you that it might be better to substitute it into the one that says y equals 2x minus 3, because then I can automatically come up with what my y is. If my x is 2, so I wanted to do that in red, my x is 2 here. What's 2 times 2, class? 4. 4 minus 3 is? 1. And I just found my y being 1. And now what we do in order to write our answer is we write it as an x, y pair. 2 comma 1. There's where our final answer should be. 2 comma 1. We could have put it back into the x plus 3y equals 5, and found out what y was that way, but you'd have to do a lot more math in order to solve that equation, just because it's a multi-step. Put the workbook away, please. Thank you. Questions there so far? Jordan?
So your answer is the point.
Yes, remember when we were graphing, we were looking for that place where the two lines intersected by graphing it? Now we're doing it by substitution. So this 2, 1 should work in both equations. Let's check to make sure it does. Okay, I'll take my green pen here. We should have 1 equals 2 times 2 minus 3. 2 times 2 is 4, so I got 4 minus 3 equals 1. Yes, 1 equals 1. Life is good. Let's check the other one. 2 plus 3 times 1 equals 5. And so we have 2 plus 3 times 1, class is 3. And 2 plus 3 is 5. 5 equals 5. They both give me a true statement. So I know that my answer is correct. So just like you did with graphing, where you can check your answer back in the two equations, you can do that with substitution as well. It's totally awesome. No graphing involved. Okay? How about we try another problem? Sound like a deal? Anybody have any other questions so far? All right, let's look at another problem here then. I have x minus y equal 3 and x plus 2y equal negative 6. As you're jotting this system down, think about which variable do I want to solve for in which equation? Because there are 3 good choices up there, I'm going to give you a hint that you usually want to solve for one of the variables that has a 1 or a negative 1 in front of it. Solve for a variable that has a 1 or a negative 1. Anybody have a preference as to which variable and which equation that we use to solve for first? Jordan, what do you think?
The first equation. Solve for y.
You want to solve for y, so you want to get rid of all those negatives and stuff? You want to deal with that? How about if we solve for the x, then I don't have to deal with the negatives by dividing by a negative. Does that sound like a deal?
Yeah.
All right, let's solve for x in the first equation, and so that's going to be 3 plus y. And this is to show you that you can solve for x too. Okay? So let's have this first equation become x equal 3 plus y. Where does that get substituted in for then? Does anybody know where that's going to get substituted in for? Anybody have an idea? Ellie?
3 plus y is going to get substituted into x in the second equation.
Exactly. It's going to get substituted in that other equation for the x. So when we write that, it's going to look like 3 plus y, that's in for the x, plus the 2y equals the negative 6. What I have in red up here is all part of that x that we had sitting in the original equation. 3 plus y plus the 2y equals negative 6. Now, y plus 2y, how much, class?
3y.
3y. So I'm going to have 3 plus 3y equals negative 6. And then we have to start solving that. Shelby, what's the first thing we should do?
You should subtract 3.
Okay, subtract 3. Make sure that you're doing that to both sides. So you're going to have 3y equals what, Shelby?
Negative 9.
Negative 9. Okay. Then what's the next thing that we're going to do along the way? Kayla, what's the next thing? Divide by 3. And what do you get, Kayla? Negative 3. So we have y equals negative 3. Remember, we want to substitute that back in. I would highly encourage you to substitute that right here in for y in that equation that you used x equals. But I will say you can substitute it in for y in the other equation. It truly does not matter. So that we have x equals 3 plus, what is y equal to right now? Negative 3. So what's 3 plus a negative 3, class? 0. Can I get 0 for an answer for x? Yes, I can. So I'm going to write as my xy pair 0, comma, negative 3. And that should be my solution, 0, -3. Notice I didn't put a box around the y equals and the x equal 1 this time. I probably should not have done that on the last one. The answer is an xy pair, so you put the box around the xy pair. Not too bad, is it? When you're substituting, you solve one of the equations for one of the variables, your choice, and then you substitute it into the other equation for that variable. Now, as I was commenting, I said sometimes you want to use something that has a 1 in front of its variable if you can, because otherwise you might introduce a bunch of fractions. And I know how much you guys like to work with fractions. So, is it mathematically possible to use it? Yes. Does it make your life harder? Yes. Okay, so be careful on that. Okay, when you have this lovely equation, what variable do you think you should solve for in which equation? Take a good look at that. Rebecca?
The negative y in the first one.
All right, and we're going to want to make it a positive y in the end. So when we're looking at this top one here, that becomes 12 minus, minus the negative. What's minus the negative, class? Plus, so we really have 12 plus 5x, right? Equals our negative y, and we have to get rid of that negative that's sitting in front of the y. So y equals a negative 12 minus 5x. Okay, this is what I wanted to keep Jordan from doing on the last one, was having to deal with all the negatives when dividing. Sometimes we can't get away from it. Okay, so I got y equals negative 12 minus 5x. This has to be put where then? Where does this get to substitute in for? Can you tell me where it's going to be substituted? Any ideas? No ideas. Jack? Y in which equation, Jack? In the second equation. It's going to go in for y here. It's got to go in the other equation. So that we're going to have 3x minus 5 times a quantity. And that quantity is negative 12 minus 5x equal to 4. When you get done, there better not have any, there should not be 2 different variables in your equation. If there is, you've done something wrong. Okay, so there better not be 2 different variables in your equation. We need to do a little bit of distributive property here. I see many of you have your calculators going there. What is a negative 5 times a negative 12, please? Negative 5 times a negative 12. Shelby?
Positive 60.
Positive 60. Then we've got a negative 5 times a negative 5. That should be easier. You guys shouldn't need your calculator on that one. What do you say on that one, please? Hannah? Negative 5 times a negative 5.
25.
Positive 25. And times the x equals our 4. We got to gather some like terms together. Kyle?
25 plus 3 is 28.
Okay, 28x plus that 60 is equal to 4. Now what do we do to both sides of that equation, please? Remember what we do, Jack? And what will you get, Jack? Negative 56. So I have a positive 28x and a negative 56. You might need your calculator to do a little division. Let's check out what x is equal to, please. What is x equal to along the way? What do you say, Jack Green? Negative 2 is a better answer. Thank you. Negative 2. Where should we put that negative 2 back into? Where should we put that negative 2 back into? Jordan?
You put it back into the equation y equals negative 12.
Alrighty, negative 2. We're going to put right in here. We can also put it in over here. If you really wanted to, you could go in this equation. I wouldn't do that because you've already solved it for y. So that we have y equals negative 12 minus 5 times a negative 2. Y equals negative 12. What's negative 5 times a negative 2? 10. So plus 10. So y is equal to negative 2. So we're going to write our answer as negative 2, comma, negative 2. And we can check our answer by plugging both of them in to the equation.